Okay, in this section we are starting a new unit, 8-1. We're starting the topic of quadratics. And so in this section we're going to be looking at several of the characteristics of some quadratic functions. And so when we talk about a quadratic function, we talk about one that has the variable to the second power. So as we notice right here, we have an x squared. That's how we know that this is quadratic. Also on the graph, we see that it's a U-shaped graph. This is known as a parabola. And so when we have these characteristics, we know we've got a quadratic function that we're going to be dealing with. Now, there's several things that they're going to ask us to find about these quadratic functions. The first of which is going to be the vertex. Well, what is the vertex? The vertex is the middle of the U-shape of the graph. All right. So this would be the vertex right here in the middle of the U-shape of the graph. All right. And so the question is, how do we find it? Well, the easiest way to find it is to use our calculator in order to find it. And we can do that. Like this. If we take our calculator and go to the graphing portion of it, and if I graph the equation that we have here, and so the equation that we have here is y equals negative 1/3 x squared minus 2x squared plus 2. And so I'm going to go back to my calculator and I'm going to plug that in exactly the way it is. Negative 1/3 x squared minus 2x plus 2. Press enter. Alright, so there's my graph. Okay, I'm trying to find the vertex, which we said again is the middle of the U-shape. Well, it turns out that our calculator will calculate the vertex for us. But we have to know how to use it. So in order to get the vertex, we press menu. We go to analyze graph. And I'm looking for the vertex. Now, the vertex can either be a minimum or a maximum depending on which way the graph is opening up. All right, and which way the graph is turned. So, in this case, my U-shape is opening downward, which would make the vertex at the top of the graph. And if the vertex is at the top of the graph, then that means the vertex is a maximum. If it were flipped the other way, where the U-shape were opening upward, then the vertex, the middle of the graph, would be the lowest point on the graph, and then thus the vertex would be a minimum. So in this case, we know the vertex is a maximum, so I'm going to press menu. I'm going to go analyze graph. And I want to pick maximum. Now, notice what the calculator is asking me. It's now going to ask me for a lower bound and an upper bound. These are the boundaries inside which you're telling the calculator to look for the maximum. So, the lower bound needs to be to the left of the vertex, and the upper bound needs to be to the right of the vertex. So when it's asking me for the lower bound, I need to drag that line over to the left of that vertex, that maximum point. Then you can click on it. Then it's going to be asking you for the upper bound, in which case you'll drag the line over to the right of the maximum point. Alright, so remember, as long as the maximum is within these two boundaries, the calculator will find it, because remember, when you set this lower bound and upper bound, you're telling the calculator, hey, look for the maximum in between these two lines. When you do, it'll find it, and it'll give me the coordinates for the vertex. It's -3, -5. So now I need to go back to my paper, and then I can write it in. All right, so my vertex here is going to be -3, -5. And once again, we use the calculator in order to help us find that point. All right, and it's actually not -5, so let me erase that off of there because it should be +5. All right, so -3, +5, -3, 5. Just double checking what we got on the calculator. -3, 5 is correct. That's your vertex. All right. What's the next thing they're asking me for here? Well, the next thing they want is the solutions. Now let's stop and talk about that for just a minute. When we talk about solutions, there's 4 words when you're dealing with quadratics that mean the same thing. These four words, zeros, roots, x-intercepts, and solutions. All four of these words mean the same thing. It means where it crosses the x-axis. It's where the graph crosses the x-axis. All four of those words can be used interchangeably, and I've seen the STAR test use each one of them. All right, so the question can say find the zeros, find the roots, find the x-intercepts, find the solutions. It all means the same thing. All four of those words mean the same thing. It means where the graph crosses the x-axis. So these words we're going to have to commit to memory. There's no way around it. You got to know what the words mean. The STAR test can use any one of the four, and I've seen them use all four of those words at one point in time. All right. So solutions. It's the place where it crosses the x-axis. The reason why it says solutions is because in some cases, like this one, there can be more than one solution. Why? Because there's more than one place where the graph crosses the x-axis. In this case, it crosses here, but then it also crosses here. So there are two places where it crosses the x-axis. So this particular quadratic has two solutions. It has two solutions. All right, now, you can try to eyeball it and say, oh, this looks like it's about -7 and this looks like it's about +1. Now, the problem with that is occasionally you may have some solutions that are decimals, and you can't tell just by eyeballing it on the graph whether it's at -7 or -6.92. There's no way to tell for sure, but we can tell for sure when we use a calculator. So let's go back to our calculator. All right, I'm now looking for these x-intercepts, these solutions, these zeros, these roots. How do I do it? Let's go Menu, Analyze Graph. Remember, zero is one of those words that means x, the place where it crosses the x-axis. And so I can, if I'm finding the zero, I'm finding the roots, I'm finding the x-intercepts and the solutions. Why? Because they all mean the same thing. I want to find the zero. And this is set up the same way that finding the vertex is. It's going to ask you for a lower bound and an upper bound. The zero that you're searching for needs to be in between those two boundaries. So I'm going to move my lower bound here. I'm going to move my upper bound here, and that's going to give me the first zero, which is -6.87, 0. So I'm going to go back now to my sheet, and I'm going to write that in. So the first solution is -6.87, 0. Okay. Now, remember there's two solutions here. So I need to go back to my calculator and find the other one, which means I'm going to go Menu, Analyze Graph, 0 again. This time my lower bound is here. Remember, your lower bound needs to be to the left of the point you're trying to get, and the upper bound needs to be to the right. What am I telling the calculator to do? I'm telling the calculator to look between these two lines for the 0. And it has found it at 0.873, 0. That's my other solution right there. So I'll go ahead and write that in. The other solution is 0.873, 0. All right. What do we want next? We want the y-intercept. We can eyeball it based on the way it looks on the graph. However, if we want to make sure that we have the exact y-intercept, we'll go back to the calculator once again. And so in order to find the y-intercept, we go Menu, but this time we go to Trace instead of Analyze the Graph, and then go to Graph Trace. Now, typically it will start on the y-intercept. I can tell by looking at this point, if it's 0, something, it's on the y-intercept. If you're not sure, arrow off of it a little bit, and then arrow back to the y-intercept. It'll tell you when you get to the y-intercept. It'll say y-intercept right there. So if I arrow off of it and then arrow back onto it, I'm at the y-intercept, and then the value of the y-intercept is down at the bottom. It's 0, 2, and so that's what we will write in, 0, 2. Now, let me say this. All these solutions are being written in a full point form, a full ordered pair, right? But remember, a lot of times we look at the y-intercept and say the y-intercept is 2. So sometimes you might just see a 2 written there. And we can say, hey, one of the solutions is negative 6.87. It's not always written as a full ordered pair with a comma 0. All right? But in this case it is. And of course we need to be familiar with both different ways of doing it. Okay, what's next for us? We want to know whether the graph has a minimum or a maximum. So is the vertex a minimum or a maximum? Well, in this case, the vertex is the highest point, and that's going to make it a maximum. All right, so in this case, the vertex is the maximum. Now, there's two other questions that it's asking us in order to finish. Okay, the first one is, what is the value to the max or the min? Well, the value, when they say the value, they mean the y value. So we need to look across and see what the y value is here. So the y value of the maximum at this point is going to be 5. And that's going to be the y value of the vertex. So if you found the vertex, you already found the value of the maximum or minimum. Now, axis of symmetry. What is it? The axis of symmetry is the line that goes right through the middle of the graph. It goes right through the vertex. It's a vertical line that kind of splits the graph in half. Now, we learned last semester that vertical lines have an equation of x equals something. Well, it's x equal to wherever it hits the x-axis. In this case, it's -3. That's also a value you can get from your vertex. So for these last two questions, what is the value of the max or the min? It's the y coordinate of the answer of the vertex. And what's the axis of symmetry? It's x equal whatever the x coordinate of the vertex is. So the answer to this question comes from this y value here. The answer for this question, the value for this question, comes from this x value of the vertex here. All right. Let's try one more example now from this section. All right. So again, I've got another equation that I need to find all of these characteristics for. So I'll go back to my calculator, and whatever's here, I need to clear it off. How do I do it? I do it with doc and B. In case you don't remember, that's how you clear off the scratch pad. I'm going to come back now to the graph, and I'm going to put the new graph in. My new graph is 1 over 5x, and it's going to be squared, so we can't forget that. Then it's going to be plus 2x. Then it's going to be a plus 6. I'm going to press enter. There's my graph. All right. And so I'm going to get to answer some of the questions. First one being, what is the vertex? Again, I'll go menu. I'll go analyze graph. I'm looking for the vertex. In this case, the vertex is the lowest point, which is going to be the minimum. All right. Since it's opening upward. Now I have a lower bound. I'll come to the left of the vertex. Upper bound. I'll come to the right of the vertex. It's telling me that it is -5, 1. -5, 1. So we'll go ahead and write that in. So that's -5, 1. All right. So there's my vertex. It's at -5, 1. And the next thing that they're asking us to find is going to be the zeros. Remember, all four of these words mean the same thing. Zeros, roots, x-intercept, solutions. It's all where it crosses the x-axis. Now, in this case, the question is, where does it cross the x-axis? Well, it actually doesn't. All right. So what that means is, what are the zeros? There are none. No zeros. Why not? Well, because the graph doesn't cross the x-axis. See, in the previous problem, it crossed it at 2 places. Here, it doesn't cross it at all. So when you're talking about the solutions or the zeros or the roots or the x-intercepts for a quadratic, there could be 2 of them if it crosses at 2 places. There could be 1 if the U-shape hits the x-axis at just 1 point. Or, in this case, it could be none. There could be 0 solutions, right? So when we're talking about zeros in solutions, there could be 2, 1, or none. In this case, it's none. Why? Because the graph doesn't cross the x-axis anywhere. All right, x-intercept. It looks like it's 6, but let's double check and see. How do I do it? Go to the calculator. We're going to go menu, and trace is how you get the y-intercept. It usually starts on the y-intercept if it can see it. It does here. It is 0, 6. If you want to verify, arrow off of it, arrow back on. It'll say, hey, y-intercept. Look at the bottom of the screen, and there it is. It's 0, 6. All right. So I'm going to come back to my paper now, and I'm going to write in 0, 6. And there we go. That's my y-intercept. And the vertex, we've already discussed that it is a minimum because it's at the lowest point. What is the value of the minimum in this case? Remember, the value, we're talking y value. When you trace it back, you can look and see. All right. I see that I trace it back and it's at 1. And I can verify that because that's the y number of the vertex. So 1 is the value, because remember, this y value is the answer to this question. Axis of symmetry, that's going to be x equals whatever the x number is here. -5 is correct. If we go to the graph and take a look, here is the vertical line that goes through the vertex, and it hits the x-axis at -5. So we know that's correct. All right, so that should be everything that you need to go through and answer the problems on your quiz for 8-1. Keep the notes out in front of you to use that as a guide for you as well. All right.